Okay, we're into section 8.1, which is sequences and summation notation. Sequences, in a very simple definition of a sequence, and probably simplified, a sequence is simply a list. Now we're going to expand upon that just a little bit. The list needs to be ordered, and it's got some kind of a defining characteristic. I think I spelled that right. Defining characteristic. There we go. So a sequence is basically, it's an ordered list. That's the easiest way to think about it. It's an ordered list, but it's got some kind of a defining characteristic, some way for us to be able to define it. So a list, mathematically, obviously, is what we're going to be dealing with, but a list could be a sequence could be, give me the sequence of all of the presidents of the United States. Well, you'd start with George Washington and then go second and third and fourth. You would just list them in order, but the defining sequence of that would be, or the defining characteristic would be the order that they were presidents in. So it is a list. It's not necessarily mathematical. There's no there's no like alphabetical listing of it or anything, but you could also do that. You could define, okay, list all of the presidents by their alphabetical last names, and then you would list them in that way. So that would give you a defining characteristic. So the biggest thing is we want to be able to write terms of a sequence and to be able to notice and kind of see what the sequence is doing. A lot of this will be pattern recognition. So let's go ahead and just jump right in. Let's do an example. If we want to write the terms of a sequence and what we want to say is the general term. So we'll call this, sorry, not number 1, we'll call this A. The first thing is A sub n is how we define the sequence. Now the sub n part is telling us which term of the sequence we are talking about. So if I define A sub n to be 3n plus 4, and I want to find the first term of the sequence. Well, n itself defines the number term. So if I want to define the first term of the sequence, I want to write A sub 1, because that is the first term of the sequence. Well, since I plugged 1 in for n, I'm going to plug 1 into n on the right side of the equation so we can see what we get. So the first term of the sequence, is going to be 3 times 1 plus 4. So 3 times 1 is 3 plus 4 is 7. So the first term, or A sub 1, is 7. If I want to find the second term of the sequence, okay, I'm going to plug in 2 for my n, which is what I wrote down there, A sub 2. It defines the second term of the sequence. So this is the first term, this is the second term, which means I plug 2 in for n on the right side. 3 times 2 is 6, plus 4 more is going to be 10. If I want to find the third term of the sequence, that's A sub 3. So then I'll plug 3 in for n. And we'll get 3 times 3, which is 9, plus 4 more is 13. And then we'll just do one more. The fourth term of the sequence. Plug in 4 for n. Plug in 4 for n on the right-hand side. And then we get 3 times 4 is 12, plus 4 more is 16. And then if we wanted to just write the general term, well, the general term is actually given to us. That's what this is right here. This is the general term. So if we wanted to write the general term, we would just say the general term, what we call the nth term of the sequence, is just 3n plus 4. That is the general term of the sequence. This is what's called the general term. Okay, and in this case, it was actually given to us. All right, let's do one more example of this so that we can kind of get the idea. This is not really that difficult, but I want to make sure that we get a little bit of practice here. So let's go with letter B. Now our A sub n, which tells us our general term, is going to be defined by -1 raised to the n power divided by 3 to the n minus 1. Let's do exactly what we just did there. Let's find the first term. We'll find the first 4 terms, as a matter of fact. So we'll find the first, second, third, fourth, and then we'll find the nth term, which is just the general term. And the good news is that's already given to us, so not really anything for us to find there. Okay, so the first term is when I plug 1 in for n. So we're going to have negative 1 raised to the first power over 3 to the first power minus 1. And then we'll go ahead and simplify that. Negative 1 raised to the first is still negative 1. 3 to the first on the bottom is 3, minus 1 is 2. So we get negative 1/2 out of that. If I want to find a sub 2, I should have left myself a little more room. I'm going to start writing a little smaller here. That would be negative 1 to the second power over 3 squared minus 1. All right, so negative 1 to the second power now is negative 1 times negative 1. Well, that gives us positive 1. And then 3 squared on the bottom is 9, minus 1 is 8. So I get 1/8 out of that. I'm going to go ahead and create myself a little more room. I'm going to erase that and write it as we go. So the third term is a sub 3. That'll be negative 1 to the third power over 3 to the third power minus 1. So negative 1 to the third power is negative 1 times negative 1 times negative 1, and that's going to be negative 1 because it's an odd exponent on a negative, so it's going to stay negative. 3 cubed is 27, and then 27 minus 1 is 26, so we get negative 1 over 26. Again, we'll do one more, which is the fourth term. That'll be negative 1 to the fourth power over 3 to the fourth power minus 1. Negative 1 is now being raised to an even power, so it's going to end up being positive 1. And then 3 to the fourth is 81. Don't necessarily expect you to know that off the top of your head, but you can figure that out. And then 81 minus 1 is 80. And then we'll write the nth term, which again was already given to us. It's just negative 1 to the n over 3 to the n minus 1. All right, we can have sequences defined by what are called recursion formulas. Recursive series is another way to say it, but these are called recursion formulas. And what a recursion formula basically means is that one term depends upon, or the term that you're trying to find depends upon something that happened before. So a certain term might depend on the previous term. Let me give you a really quick example of that. Some of you may have seen this, some of you may not have seen this. There's a really famous sequence which looks like this. 1, 1, 2, 3, 5, 8, 13, 21, and then it just keeps on going forever. But if you haven't seen this, what's happening here is the first two terms are defined. Okay, this just has to be given to you. So that one has to be given to you, and that has to be given to you. But what you can see is that the next term, 2, is the sum of the previous two terms. This 2 right here is the sum of those two terms. Then this 3 right here is the sum of the previous two terms. Then this 5 right here is the sum of the previous two terms, the 2 and the 3. And then the 8 is the sum of the 3 and the 5, the previous two terms. And that's the way this specific sequence is defined. After the first two terms, every term thereafter is the sum of the previous two terms. This one is actually known as what's called the Fibonacci sequence. Again, if you had never heard of that before, it's called the Fibonacci. Let me make sure I try and spell this right. I think it's CCI, Fibonacci sequence, named after the person who discovered it. Anyway, that's what a recursion formula is. So let's go ahead and take a look at how we would actually see one of these defined for us and how we would use it. So let's go ahead and call this example 2. All right, so we are going to be told we want to find the first 4 terms. we're going to be told that a sub 1 is defined to be 5. But we're going to be told that the general term, a sub n, is 3 times a sub n minus 1, we'll talk about that in a second, and then plus 2. For n is greater than or equal to 2. It just means starting with the second term, we're going to use the a sub n because a sub 1 is defined for us. So if I want to find the first 4 terms, well, the good thing is that a sub 1 is given to us. A sub 1 is just 5. That's our first term. Our second term, however, is going to be based upon this formula. So a sub 2 is based upon that formula. So here's the general idea. I just plugged 2 in for n. I'm going to plug a 2 in for n on the right side of the equation. So what I would get is 3 a sub 2 minus 1 plus 2. But the sub 2 minus 1, well, 2 minus 1 is just 1. So really what that's telling me is that to find a sub 2, I'm going to do 3 times a sub 1 plus 2. But a sub 1 is what I had from the previous answer. A sub 1 is right here. That's 5. So in order for me to figure this out, I'm going to substitute in my a sub 1, which was 5. So it's going to be 3 times 5 plus 2. 3 times 5 is 15, plus 2 is 17. All right, let's see if we can continue that process. If I want to find the third term, that's going to be a sub 3. Once again, I am substituting a 3 in for n. So in the formula on the right, I'm going to substitute a 3 in where the n was. So it'll now be a sub 3 minus 1. And then don't forget your plus 2. But again, 3 minus 1 in the subscript there is 2. So really what I'm looking at is 3 times a sub 2 plus 2. But a sub 2 is what we found in the previous step. So that 17 is going to take the place of a sub 2. So we get 3 times 17 plus 2. 3 times 17 is 51, plus 2 more is 53. So there's our first 3 terms. Let's do one more. So we'll do a sub 4, which is 3 times, if I plug 4 in, I'm going to save a little space here. If I plug 4 into the n, that's going to give me a sub 3. So again, as you can see, that a sub 3 right there is the previous answer. A sub 3 is the 53. So we're going to do 3 times 53 plus 2. And 3 times 53 is 159, so plus 2 more is 161. So that gives us the first 4 terms of the recursion formula. So we have found the first 4 terms. And if it asks you to list the sequence, you might see it written in different ways. These are the first 4 terms. A lot of times we say, okay, the first 4 terms of the sequence can be written as 5, 17, 53, 161, and then because technically this thing will go on infinitely, we just put a dot, dot, dot. A lot of times they like to list the general term someplace after that. In this case, I'm not going to worry about doing that, but that would be another way you could see this listed.